Hello everyone, today we're going to take a look at this little Nvidia Flex particle patch. It's going to be a little bit different from the usual Nvidia Flex setups you see. I mean like really like a little bit different, but it makes a whole lot of difference in the outcome. As you can see, there's a few like these lines that seem to have their own little life going on. And those come from using the complex OP somewhere in the mix. We're gonna take where that is. And the other aspect of this little video is gonna be how we can use the OpSequencer to create these beautiful transitions between scenes. I mean, not scenes is the same patch, but between presets of a comp. This is not new in terms that I've released the OpSequencer before, but I haven't really dedicated a video where I'm creating something beautiful with it. So this is it. This is going to be more of a rundown video. I'm not going to do an Nvidia Flex tutorial because there's many out there that probably do a good job already. So I'm just going to do a breakdown and show you the little differences that make the big difference for me. So this project file is available on my Patreon, as well as many other things, including the tools that you see me use in this video. If you're already on my Patreon, thanks for the support. If not, check it out. There's a lot of backlog there, and there's going to be a lot of stuff in the future also. So this is the Nvidia Flex setup here. We start with sprinkled points on a sphere, 50,000 of them as the starting position of the simulation. So if I were to reset this, they would start from that sphere. We also have a bounding box, 1 by 1 by 1. This bounding box is defined here in the Nvidia Flex solver bounding box sub. And then we are instancing points. So there's nothing like crazy here. We are using the Nvidia Flex solver that has a feedback. Sorry, the actor has the feedback of the position and the velocity. So basically we start with these positions as a sphere that is defined here in the instancing tab of the actor, but then actually what actually creates the actual positions, or like dictates the actual positions, is the position feedback top. That's going to matter in the end. And velocity feedback top is also there to keep it in the loop. And then we have the Nvidia Flex solver comp here, which refers to an actor or multiple actors and forces. I think I didn't mention that I also have a force here, a spherical force. As you can see, this has an effect if I mess with it. So yeah, that's kind of your basic Nvidia Flex. And yeah, we have the Nvidia Flex top, which receives the position, velocity, blah, 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 from the actors or an actor. And what you usually do is actually not even use, you're not like required to really use these feedbacks, because if I were to remove this, the system still goes on. It's just that the behavior is defined by the Nvidia Flex solver comp. But by using these feedback tops, we can add extra influence to the system. So in this case, with the position, what I'm doing here and what's making it look, I think, a little bit more unique than other setups is that we have a complex OP here with a blend of a 0.002, like super small. If I remove this, it still works, it's still acting, but there's a lot of the magic that's missing for me. I also have a cross here actually, and the cross is the cross between the current position of the particles and the starting position. So also if I remove this cross, some of the movement disappears, and this is like we're not even using the feedback because we're not doing anything with it. So this is where we can kind of mess with the system a little bit. So by adding this cross, to influence the particles to go back to their starting position, we create this kind of nice movement here. And as I mentioned, by adding a little bit of a complex OP magic, we add some kind of a chaos or uncertainty to the system. We can see the effect of complex OP here. So this is without complex OP in the mix. Let's give it some time to kind of stabilize. But if I add some blend, so like mixing in the complex OP just ever so slightly, we can see what happens with the texture, and this creates the magic for us. Don't ask me what happens exactly, because I don't know. So this was the first kind of modification that I did to the system, to the Nvidia Flex system, that made it look a little bit more unique. And then the other one is when it comes to coloring the whole particle system. So for the color, I'm taking the velocity of the particles, and I'm just calculating their vector length, their vector magnitude. I don't care about their direction. I don't care about the individual x, y, z velocity. I just care about its magnitude. So to do that, we can combine the RGB channels with the pre-OP to make them squared, then add them together, and then root the resulting value, and then I output to the RGB so that we have a monochrome, nice texture. I then added some exponent function to influence better the distribution of colors when it comes to the speed, and then I just did a lookup top with a color palette of my choosing. So without without this function, there's not really a huge separation between the colors, and with this function exponent top, yeah, we can just add a little curvature to the lookup. That's basically it, and then we're using that as the instance color texture here for the actor. So there's not much magic going on here. That's the Nvidia Flex setup, and for the post effects, there's also some little tricks here. I mean, not much. First of all, obviously we render it to render top. Then I put down a level top to make it 32-bit float. And the reason that I'm doing a level top after the render and setting this level top to 32-bit float, I mean, okay, first of all, I'm changing the brightness and the gamma. That's one thing. But even if I wasn't changing the brightness and the gamma, I would just put this level top down and set it to 32-bit float here, as opposed to setting it on the render top. Because if we take a look at the stats of this render top, okay, we are about 0.2 milliseconds, 0.1 milliseconds on the CPU, on the GPU, and the memory is like 60 megabytes. But if I set this to 32-bit float on the render top, in terms of cook time, we are about the same. We are a little bit more GPU cook, if I'm not mistaken, but we've significantly increased the memory. What was it before? It was like we gave an extra 100 megabytes of memory, as opposed to the level top, which is only 26 megabytes, and this is already 32-bit float. If it was also 8 bits, it's 26. Actually, we didn't even increase the, oh wait, let's put this first. Okay, 60, 26, 6. So it's only a 20 megabyte increase when I set the pixel format to 30-bit float on the level top, as opposed to the render top. And my working theory on this is that the render top actually contains a lot more information than just the texture, because for example, when you do like a render pass or a render pass, you refer to this render top, and then you can, you know, do some other operations on it. So I think what happens is that yeah, basically this has a lot of other information in the background that also needs to be casted to 32-bit float, thus increasing the memory usage of this. Just a small optimization trick here. Okay, then I have a feedback feedback network here, nothing extraordinary. I'm using the screen operation, adding some blur to it. Without the blur, it's quite sharp. And then I have a level here, and I mean, I'm messing with the opacity. I gave the brightness 2 here as like a, it's kind of like, for me, like a trim, like trimming the opacity back even more a little bit. And the gamma just works well for me sometimes to mess with. So that's kind of personal, I guess. Then I have another level top, God knows why. But then here's one of my little tricks that I like to use. Basically, without what this does here is like adding bloom, but let's see it without the bloom. There's not like a huge difference, but still there is some. Let me place my camera on the other side. Okay, so there is some difference, not a huge amount, but I kind of like it better with this bloom. But my problem is that through this feedback, we already get quite a lot of brightness, even without these level tops that actually cut back on the brightness. So we have accumulation of whites here that I actually don't want to affect with the bloom. Like the standard bloom, if we just use that, we can only affect the bright parts of an image. So we can make brighter parts even brighter. But what I'm doing here is actually I'm more taking a color slice from the mid-range of the colors, or even the like darker colors, and adding bloom to those colors as opposed to the bright parts. So here I have this threshold color little comp. There's nothing extra here. It's a threshold with a multiply of the original image, and I'm softening it obviously also. So first I cut down the highs with the greater comparator. I cut down the bright colors, but then if I just use that, there would be a lot of dark parts that I actually don't want to put bloom on. So I then cut down on the very dark parts of the image, also with some softening. And yeah, that way I can affect kind of the mid range of the brightness. Yeah, with this bloom, with some personal specific settings. Actually, this looks better. And then just using a screen composite to then glue them back in. Again, a level top. I messed a lot with the levels because I kind of was never fully happy with it. I think now I am. Transform top for the background, and this is not needed. So that's kind of the setup here. What was this here? Oh yeah, sorry, backtracking for 1 second. I'm also affecting the size of the particles. So I'm taking the density of the Nvidia Flex output, fitting it just to make sure that everything is the correct size, because there's been some issues with Nvidia Flex and yeah, not correct instance count. Anyway, so I'm just taking the density, which I don't know how it is derived actually from Nvidia Flex, but somehow we get the density of the particles, whatever that means. But then I'm just scaling them a little bit. So like this would be like if everything is the same size, but if I take down the size of the particles that have a low density, we get a little bit nicer contrast between the particles. Actually, this is better. This 0.3. Yeah, and then that is used as the scale for the instances. Yeah, so that's the Nvidia Flex part, and obviously I exported or like promoted some parameters from Nvidia Flex to affect the system nicely. For example, I have a scale which scales the bounding box, which works super nice when we scale it on the z-axis. Okay, now we have too much bloom. But yeah, if we scale it differently, okay, let me change the bloom. I think we overdid it with the intensity here. Cool. So we can kind of squash this particle system in nice ways. Let me look at that. That's so cool. And then I have the flex cross, which I showed before, crossing between the original positions and the full flex system, which I leave just slightly below the full. I have the feedback opacity for fun, and simulation speed. Gravity also, yeah, this dies when you put it at 0, so I need to reset. Simulation speed, gravity. A lot of people have asked how I did the motion of the particles with the webcam motion detection tutorial. Well, it was this parameter, the gravitational acceleration of this system. I have adhesion here, adhesion of the particles, dissipation, cohesion, smoothing, which is like actually the opposite of smoothing. It's not smoothing. I have the strength of the force, which is a spherical force, and the radius of that force. So these all look super nice, and obviously the blend of the complex OP. If I put it on a higher value than 0.02 or something like that, it kind of gets crazy, but you know, it has its own charm. Yeah, but it works well with 0.02 for me. And then just the, I think it's the level of particles or something, or maybe I'm not even using this. Anyhow, so I have these parameters here, and using my function sort tools toolkit, it's super easy to add new parameters to the parent. You literally just drag and drop something here, or you drag and drop something over here. Now it's per pane, so I could actually promote it to some other component if I wanted to, or I can just drag it to here or here. There's a lot of options how you can promote parameters. I usually drag it to the diamond, and that way it's promoted to the parent, easy as. Okay, we're actually not going to use this. And then once we have this little setup of our component, we can use a preset system, and there's quite a few around, but I haven't seen any that you can control with chops. First one that comes to mind is Alpha Moonbase's Tausati preset system, which I use a lot, but that you can only navigate with a MIDI controller or with a Python script, or basically on demand also with a chop, but it's always going to be a timer that operates it, and there's specific reasons why it's like that, and there's good reasons why it's like that. But my preset system works with a chop input, so I can go between presets using this select slider here. And what I've done here was basically I just played around with the parameters, as you saw me do before, and I added new parameter. I added new presets to my preset system. But yeah, let's start from scratch, let's say. So I'm just gonna drop the OpSequencer here. I'm gonna park this one for a second. And how you would start is, yeah, you have the OpSequencer, which is available on my Patreon again. you drag and drop something onto this OP parameter here, but you do so while holding Alt on your keyboard. And what that does is it will add all these parameters already to the preset system. Otherwise, you would have to drop them, activate this, and drop them one by one onto here. So this just saves you some time doing that. And once I'm done doing this, I already have one preset. So this was our initial preset. And then I can change some parameters. Let's see. I want to change. Yeah, I guess this looks cool. Yeah, you know, this is whatever. Let's change the scale. Let's squash these particles and then scale up actually this. Cool. So this is my second preset now. Looks amazing. What I need to do now is either hit append here or activate and hit append here on the UI. And now, either on the UI or in the parameter, I can simply go between these two presets. Now we're using the easing function in-out sign. I can override that because that's what we saved it with. But I can override that we are using the same easing function for all the presets. Let's make one more. Actually, I'm gonna change the simulation speed. Looks nice. Gonna add some adhesion. Yeah. Okay, simulation speed low. All right, that's looking great. I'm gonna append this to my preset list. And then there's already an expression here to go between presets with appstime.seconds. And we can see the parameters animate themselves. And we're going from preset to preset. Right now, as you can see, we are spending most of the time between presets. So although we saved the presets to be in one state, we are never really lingering on that state. We can do that a little bit more if we use higher order curve. So for example, if we have a look at the easings.net, we are currently using in-out sign, which would be here. But for example, we can see that the exponent one is a little bit more extreme. So I'm just going to use that one. Because we are overriding the easing curves, we can change it for all of them. So I'm just going to use, actually I'm going to use out expo. So if you take a look at the parameters, now we are quickly changing the parameter and lingering around those, I mean the set parameter values longer. Obviously we can slow down the transition a little bit more. And you can basically drive this select with anything else but an appstime.seconds. So you can build your own lookup curves even if you set this to linear, or there's even a custom lookup curve option here. So if I put an S curve here, and I want it to have like a super steep, aggressive preset change like this, and I set this to custom ease, this will now use our lookup curve. You can see it stays the same for a long time, and then suddenly it's going to jump. I think it already did. Come on, where's the next one? Yeah, like a big quick jump. So yeah, you can just drive this select parameter with anything you wish. Something I forgot to say. So if I still wanted to mess with the parameters, obviously this is now driven by the OpSequencer. So what I can do is, for example, I can unbind this so that I can not freely change the parameters, but then if I bind again, Actually, no, I can unbind and hit append. That will append at the end of the list this new preset. But if I wanted to insert in between stuff, because this is now driven, I mean, this select is now driven by the apps time.seconds, I cannot really do that. So I could, if I wanted to insert before number 3, I could set it to number 3, click insert or replace or whatever, and then re-enable the expression and or re-enable the bind. So that's just a quick extra information. Oh, also, there's an any to any option that's been added, and this lets you go between any two presets instead of a linear, sequential order. I don't really use this, but I think this can be useful for some people, for sure. And in some situations, I'm sure I will use it at one point. Okay. I think that's basically what I wanted to talk about. The original presets are going to be included in the project file. And yeah, I hope there were some useful information in this tutorial, and yeah, I hope I gave you some ideas how I kind of quickly build different presets and stuff like that. So yeah, thanks for sticking around. Join my Patreon if you are not already there. And yeah, the project file is there for download and dissection and reusability and whatnot. So thank you, bye bye.